Hello, this video is for my chemistry students. Okay, it's for the energy and stoichiometry paper that you have due early next week. I wanted to go through a couple of examples with you. I think you'll find these a little easier than some of the other ones we've had because we don't need to change moles into kilojoules. Okay, so first of all, what is a kilojoule? Well, a kilojoule is a unit of energy. Okay, it's 1,000 joules. So 1 joule will heat 1 gram of water up by about 1/4 of a degree Celsius. Okay, but it's a standard unit of energy that's given in chemistry. So its abbreviation is kJ. So let's take a look at this first problem here. I notice an English mistake that should be R, not is. Okay, because grams is plural. So the English department wouldn't like that. So anyway, first thing we need to do is look at this and write down a balanced equation. So sodium carbonate, Na2CO3, remember sodium is +1 and carbonate is -2, so Na2CO3. Oh, let me introduce big virus here and little virus. Okay, they're helping. And sodium bicarbonate, when it's heated, so we'll put heat here as a reactant, decomposes into sodium oxide, Na2O, and carbon dioxide gas. So we can predict the products there. It's a decomposition reaction. Now, we're told that 1 mole of sodium carbonate is decomposed by 45.75 kilojoules. So we can set that up in our molar ratio. So 1 mole of sodium carbonate corresponds with 45.75 kilojoules. Now, remember I said this was our mole box? Well, I lied a little bit. I'm sorry. We could put kilojoules in there. We don't need to convert to moles. Okay, there are 2 different types of units. Now let's set that to what we know here. Okay, so we have 256 kilojoules, we actually have, and then solve for X. X is going to give us moles of sodium bicarbonate, or sodium carbonate rather, and then we'll convert that to grams. Okay, so let's take this, 256 times 1 divided by 45.75. That gives us 5.59 moles. Okay, so 5.59 moles of sodium carbonate. Just cross multiply and solve for X. Now that's moles of sodium carbonate. We need to convert it to grams. So how do we do that? Well, remember, going from moles to grams, we multiply by the molar mass. So let's find out the molar mass of sodium carbonate. So we have sodium, carbon, and oxygen. So 1 sodium, its atomic mass is 23 grams per mole. Carbon, we have 1 times 12.01 grams per mole. And oxygen, we have 3. I'm sorry, we have 2. Okay, 2 sodiums there, my mistake. So 2 sodiums, 1 carbon, and 3 oxygens. So that's 46 there, 12.01, and 3 times 16 is 48. Okay, so that's the molar mass of sodium carbonate. Let me move this up a little bit. Okay, viruses have to move too. And then we add these up, and it's 106.01 grams per mole. So that's the molar mass. Now to go from moles to grams, we multiply. So 5.59 moles of sodium carbonate times 106.01 grams per mole. We do the math there, and we come out with 593.7 grams of sodium carbonate is decomposed. Okay, so that's our answer. So we balance the equation, we predict the products, balance it. Heat is a reactant here. And then we set up a molar ratio between the sodium carbonate and how many kilojoules it takes to decompose 1 mole. So 1 mole corresponds with 45.75 kilojoules. We set that to what we actually know. We actually have 256 kilojoules, and that's X there. You solve for X, that gives us the moles of sodium carbonate. Going from moles to grams, we multiply by the molar mass we calculated, and we get the number of grams. Okay, let's try one more here. So this one, we're trying to find the amount of heat. Okay, so here we have methane reacting with oxygen, and it gives off energy, gives off heat energy. Okay, so it's an exothermic reaction. The first reaction we saw with sodium carbonate was an endothermic reaction. So here we have methane. Okay, methane, the formula is CH4, reacting with oxygen, and hydrocarbon with oxygen, that's a combustion reaction. So our products are carbon dioxide and water. So hydrocarbon and oxygen producing carbon dioxide and water. Now let's balance it up. Okay, remember carbons first. 1 carbon, 1 carbon. That's okay. 4 hydrogens, 2 hydrogens. So let's try putting a 2 here. So that's 4 hydrogens, 4 hydrogens. Save the oxygens for last. So now we have 2 oxygens here and 2 more, so that's 4. So if I put a 2 here, that's going to make it into 4 oxygens there as well. So now it's all balanced. So let's set up a molar ratio. Okay, so 1 mole of methane over 890.1 kilojoules. Okay, we're told that. So 1 mole of methane releases 890.1 kilojoules of energy. Now, let's set that to what we actually know. So we know we have X kilojoules. Okay, we're trying to find that out. And we have grams of methane. But we need to convert that to moles. Okay, so going from grams to moles, we divide by the molar mass. So let's find the molar mass of methane. So it's carbon and hydrogen. 1 carbon. That's the atomic mass of carbon, so 1 times 12.01. And hydrogen 4 times 1.01. So that's 12.01 here and 4.04. We add them up, and it's 16.05 grams per mole. That's the molar mass of methane, CH4. So now we need to find the number of moles of methane we have. We have 17.8 grams of methane divided by the molar mass, 16.05 grams per mole. And we do the math there. Okay, we get 1.109 moles. 1.109 moles of methane. Okay, so now we can put moles up in here. 1.109 moles of methane. Now let's do the math. Okay, so 890.1 times 1.109 divided by 1. That comes out to be 987.1 kilojoules. So X equals 987.1 kilojoules. And that's our answer. Okay, so let's review. We set up and balance the equation. So methane reacting with oxygen, producing carbon dioxide and water. It's a combustion reaction. We balance it. We're told 1 mole of methane releases 890.1 kilojoules. So 1 over 890.1. And then we're trying to find the number of kilojoules here. We have grams of methane. We need to convert grams to moles of methane. So find the molar mass of methane. 17.8 grams of methane, we're given that. Divided by its molar mass, 16.05 grams per mole, gives us a number of moles. Okay, 1.109 moles. We can put moles up here for methane now and solve for X. So X is 987.1 kilojoules. And that's our answer. Okay, so check on Veracross for the assignment. Okay. It will be due next Monday. Okay, email me if you have questions. Okay, I hope you're all doing well. Some of you may have noticed the focus on my camera. I have to fix that. I think it's a white background is affecting it as well. But say bye to the viruses here. Hope you're all doing okay. And I'll hopefully see you soon. Bye.